Hello and welcome. I'm Bill Wake. We're here working on the top simulator. We've been doing it for a few episodes, and I think we're going to make today the wrap up. Let's see. Let's get over to the IDE. And along the way, we see that our tests are still just jammed up there. I think kicking off the simulator must be the slow thing that makes it hard to start here. All right. So what we're going to focus on, we've got this notion of a one pixel space, and I think we just finished adding it as a default element in the library. And I think we also just want to add one letter just to kind of prove we can do it. What I want to do is when you put a series of pattern names like H space I space exclamation point, I would like to treat those spaces as a one column blank, blank all the way down. Okay, so I guess I should quickly introduce, if you're just joining us, we're simulating a top that has a little row of LEDs. When you spin the top, the LEDs basically turn on and off, flash patterns, and you can get it to say letters and stuff if the timing is just right. I'm kind of fudging the timing as far as simulating it, but I'm trying to do a design where we define things in sort of a pixel grid and then convert that to a dot and dash pattern, kind of LED by LED, and then convert that to the arcs that actually represent the circle segments in the spinning top. Okay. And there we go. Okay. So we've got the notion of the main top page, a library page, and then a grid you can edit. And we're trying to work on the library to give it a little bit of extra stuff, and then work on the UI to make sure it picks up that little extra bit of stuff. And the reason I pulled this in, I'm looking for, well, I was trying to find a tokenizer or split that would let me keep the spaces ideally merged, and I didn't find it. But at some point, something like this we could probably get by with something like this. If we split it by spaces, and then that gives us a list of stuff, and then we join it with another element. Okay, so I think we get that for free on Sequence. We may have to do a little work to match the types up and all that, but I think it's doable. All right, so let's see, the one pixel thing. I'm going to close everything else. We'll open up the library. Okay, so here we've got a library. It's more or less a wrapper for this dictionary key to pattern. It records that we have to be hashable and comparable, and which is what the dictionary requires. The one thing we do that's, well, two things. One is we do give a default value, so if you don't find something in the dictionary, you get a default. And the other is if you ask for the list of keys, they come back sorted, which is nice for our library view, which is going to be the grid of all those patterns. All right, and then let's find content view. Let's see where we're creating our library. Yeah, so the library, it's string to pattern, default value is pattern empty, initial contents, I put a space character, and it goes to a pattern with one pixel false, which means one off pixel. If you match that up with any kind of grid element, with any of our patterns, it extends to the same height, so and with all falses, so it would be the equivalent of a one column blank. Okay, so the library has that. We confirmed that running it. I'm just going to kick off a run just to kind of get that part of the build going while we look around. All right, and then what we want to do is let's find the go button. That's in content body view. Okay, I still don't know if I'm doing the best way to separate out these views, but the content view, I've got all my navigation up in there, and the body views represent the contents of that front screen. Okay, so yeah, it's gonna run. All right. Let's see. So is anybody? Well, this gives us a default top when we start. We're not quite there yet. All right, 1 second. Just excuse me. All right. Yeah, there we go. All right. So it's a sort of a 3/4 ring, a half ring on the top, a gray ring on the bottom, and a yellowish orangish ring around. Okay. And that's reflecting this. The order is random just to kind of prove that it doesn't matter. But 0 to 180, that's the top half one. 180 for 180 is the bottom half, and 270 all the way around, 360, or the little partial C shape. Okay. So we get the stuff for free. I mean, that's fine. You got to show something. I think at this point, you wouldn't blame me if I put the rings in order. We'll fix the comment in a moment. Okay. And that's allowed. Fine. Okay. And the go, where's that? Yeah, go. Okay, so right now we've delegated all the work into TopMaker, and it's producing the arcs. Now I think there's a little balance of types. We're probably, I don't know. I don't think we really want to know the arcs at this point. I think that's more should be well, actually, these aren't the arcs. That name is probably not very good. These arrays of doubles are really the dashes, and that's really the programming of this thing. Like stay on for 2 beats, go off for a beat, on for 2 beats, off for a beat. You know, you get a wide stripe kind of view. All right. But in any case, TopMaker is the thing doing the work right now. I'm going to name this to dashes just to start getting us. Let's shift the vocabulary to what it really is. These arrays of doubles are dashes. They're not arcs. And dashes because lots of times if you specify dash patterns, they do something where you specify how much on, how much off, and you can either, if you did 3, 1, then it's wide dashes. If you did 3, 1, 1, 1, it's wide dash, narrow dash, and then they just repeat. All right. And then same thing here. Let's go to 2 arcs. Okay, and this is on the pattern, and I think I'm going to say the same thing. Rename this. 2 dashes. Okay. All right. Now back here, we'll go to TopMaker. Let's keep that around. All right. Now this method, it's not directly well, it's in the UI stuff, but it's a testable method. So let's get our tests up for this. Okay, so I don't know what we've probably just a build issue. Outdated build. Okay, so our test, we're going to create a TopMaker with a library and an empty pattern. If you ask for nothing, you should get nothing, right? Let's make these empty dash pattern. I think dash pattern may be the name we're heading for. Okay. 2 patterns concatenate. I think that's probably just true enough like that. Okay, so what I think I want to change Well, I would like to say, I would like to say this pattern, one dot space one dot, should really become one, one, one. One for the first dot, one space for our space, and then one for the next dot. Okay, so let's change the expectation. All right, now, obviously the tests all passed a minute ago, and I just changed the expected value, so I presume they're going to fail at least this one test. And the point will be, what do I have to do to get that space joined in there with it? Okay. So what did I get? I got 2 0 or 2 0 instead of 1 1 1. Right. Okay. I mean, that's testing the runs, which is a good thing, the original. But in this case, we're trying to prove something about the top maker. Okay. So here it splits. It maps the library. A library returns a pattern, if you remember that. So this is producing an array of patterns. Let's see if it knows that for us. Yes. Okay, so I want to try this thing I looked up after we stopped yesterday. I want to try joined with a lookup of space. Now, do I need the space in the library? Maybe it doesn't belong there. But okay, but let's see what we can do. So this could be joined and takes a separator. I think this is the reality of what we have now. Library, okay. Requires that pattern conform to sequence. You would think it would require that array of patterns conforms to sequence. Okay, let's let joined equal patterns dot. I'm just breaking it up so we can figure out better. Instant method requires pattern to conform to sequence. That's just not quite what we want. Returns the concatenated element of the sequence of sequences. Oh. No, that's just not what we want. Oh, why is that such a hard thing? I mean, I thought this would work. Let's see. Let's see if we can find an example somewhere. Swift joined. Oops, I should say example. A string array contains many strings. All right, so Swift joined. Let's get that string documentation up. Oh, that's the array one. Generic instance method. String the separate between each element. Oh, there's the example. One, two, three. So it preserves the contents of each element. I mean, sometimes you can do these. Let's look for this with arrays. I'm hoping somebody has a similar enough problem. what can I do? Maybe the problem is the split. Is there some other alternative? Split a string. Separate a character, omitting empty subsequences. Returns the longest subsequences. Subsequences that don't contain this element. The omitting empty subsequences, if I get 2 spaces, it can return me an empty string that represents it, but yeah. Split separator. I don't know, did we look for this Swift split string retaining spaces? No, that's TCL. Apparently. How many results? Okay, keeping. Well, oh boy. Okay, I mean, what we can do, let's pull this back together. All right, I think I can wrap the extra level, and what's pattern's going to be now? An error. Oh, pattern has to conform to sequence. I don't understand why pattern gets involved at all. I mean, it's returning an array of patterns. An array definitely conforms to sequence, but okay. Well, how about, can we interleave sequences? Do we have zip? Because that's what I want. Use zip function. Okay, so zip the two things. All right, so let's build a spaces. Repeating. Line burst of space, and then we want to go patterns dot count. We have to be at least as long. We're going to get an extra one on there. That might be acceptable. Well, maybe not. Okay. And try let joined equal zip of patterns and spaces dot drop last. Okay, is that gonna be? Does it know zip? So I think this zip takes two lists and creates a list of tuples. And then do we flat map it? Is that what they did here? Yeah. Okay. So I think zip puts the pair 1, 2 together, 3, 4, 5, 6, and then this flat map is going to take each pair. Yeah. Let's try that. Yeah, drop last is probably not dot flat map. And then it's, yeah. Okay. Dot drop last. Okay. Now, and then we take the patterns, concatenate them and convert it to dashes. Okay. Let's run that test. That's a long, oh no, joined. I gotta do joined here. Okay, try that again. There should be a simple operator for this, and I just can't believe there isn't. I want something analogous to the string one at the array level, but it doesn't happen. Okay. Now, what's your problem? You're still 2.0. Okay, now that puzzles me, so we'll just stop right here and take a look. Oh yeah, got to turn the debugger on. All right, so if we look at patterns, all right, so patterns should be the two looked up patterns for one dot, okay, which is the Boolean true. A little hard to tell here, but maybe we can get the, no, can't quite get the value. Okay, now spaces should be a bunch of patterns equal to the number of things we have. And they should really be the same pattern, which we see they are. And then joined doesn't exist yet, but we'll step over. Okay, where's joined? Let's just do a print. Hope for the best. Okay, what we got? Well, joined is for patterns, which should be one dot. Ooh. They all look the same, don't they? EDC20, our spaces didn't get merged in there. Did I type 01? Okay. All right. Let's try again. Let's do this. X, Y, N. And then I think we can see it better. Did I zip the right things? Patterns and spaces. Okay, we'll step over. Print X. Print Y. Okay. We seem to have 66FO and F70. And if we step over again, I guess it should be the same thing. Oh. 66FO F70. Okay, so I feel like we got the flat map should be creating. It should have the two lists of stuff. All right. Now, why is that 4 times? Print X. Cannot find X. Okay. Okay, now let's print joined. How did they go from... It's like we didn't drop the last. Okay. That's joined. I don't know. I mean, these things should just... Maybe the drop last is... We're going to have to... We'll close this back up, but I just am not seeing the pieces. So maybe the question is, what's a smaller byte? Because here I am running the debugger twice, 3 times. And the pattern name seems correct. Okay, so our 2 patterns, CAD 200. Okay, that's right in both cases. Then spaces are 1E, A0. All right, so let's print spaces 1EA0, 1EA0. Okay, and then we will step over 2, 3, 4. Okay, now let's print joined. CAD 200, EA0, 200, EA0. Okay, and if I step over and we print final, it should be the first 3. Whoops. CAD 200. I guess I'm just reading this wrong. No? Oh yeah, no, that's okay. So we have pattern space pattern in order. All right, and so we expect false, true, false. Okay, let's break on 2 dashes. We'll continue. Okay, so now pattern. Where's that coming from? Oh, that is on pattern. Okay. So let's print pattern. True, true. I don't know why we don't have true, false, true at this point. If it comes in with true, true, it's definitely going to do that. All right, let's go back here. Final. I'm going to split this out too. Okay. Golly. Okay, and let's break here, see if we can reconstruct enough to see what's going on. And that reduce is correct if he's given just the 2 booleans, but it seemed like final had 0, 1, 2. Okay, so where are you there? I don't know how I got there. Did I run the wrong? You shouldn't call 2 dashes until you've at least stopped here. Okay. Let's print partial. Wow. So what is partial? Is a pattern. Okay, print. Two values. Ugh. So our reduce did not. Gosh. Okay, let's print final. Count should be 3. $11.30. 350. 1130 again. Okay, print final sub 1 dot pattern. Should we just, whoops. This should be one Boolean false. It is empty. Is our concatenate not working right? Okay. That's where my suspicions are at this point. Well, no. How did it get there? It is empty because we don't have this production library. So let's put the let's make that a special element too. We had it empty, but I think we could also have dot how about thin space? Okay, and let's go add that. Okay. And we'll just run that quick. Whoops. Pattern false. I'll run all those. We still have a breakpoint. We'll have to kick out of that. It crossed my mind when I wrote that code. Take off these. Okay, we're due for a break. Let's take a break and then debrief that a little bit. All right, 2 or 3 minutes. Hi, welcome back. All right, so what happened? All right, let's start back at the test. Okay, so the thing here is we defined the default value, but we didn't do anything to put the space pattern in there. And I don't know that we necessarily need it in the library. Maybe that was a foolish direction. Okay, so let's see. I guess I could put this in to do, just a little bit of debriefing. Okay, so one thing is we couldn't find an operation to produce, well, to split string but keep spaces. Okay, so that's one thing there. So partly this is me not being super familiar with the operations. I mean, it'd be nice if I had this list in my head of the 15 operations that you can do, or the 30 or 50 or whatever it is. But not only do I not have that list, I don't have the search skills to find it if it exists. Okay. And I guess also joined wasn't quite right. Okay, because we're kind of simulating that right now. So that definitely happened. Let's go back to the test. This part I'm fine with. The top maker, I mean, so we're using simulate this with zip plus flat map. Okay. And that's, well, it's not really what we wanted. Like, notice we had, plus drop last. Okay. Because you had to have both strings equal width, or only the shorter one gets taken, where really I just want to intersperse one thing with it. Okay, so that's an awkward thing. Then with the issue of the thin space, it was not in the library. Okay, that's a production decision. Okay. Well, it's not there for tests, but is there for production, which I think I may take it out because this code is the reason we need that entity. Okay, was not in the library. Okay. Yeah, now what mental patterns for me made me go in the wrong way here? So I don't think it was terrible. I don't think it was terrible to split these up. I mean, just to make it easier to debug, because the debuggers, there are tools that are sophisticated enough to let you hover over one of these and see what goes in or something like that. Not this one. Okay, that's fine. It is what it is. Breaking it up seems okay. Checking the various places seems okay. But when I looked at final and saw final 0, final 1, final 2, they all look like Boolean arrays, which sounded fine, but I didn't notice that there was no value in that second Boolean array. And the no value thing made things blow up. And the no value thing, okay, let's see. So what am I going to say? Didn't notice empty array while debugging. Okay, so if we'd seen an empty array on final 1, okay, and so this may be, I don't know if I want to say solutions. Okay, but we didn't notice it. Suspicions. So first, the pipeline. Okay. The second one, I started worrying about plus. And then finally, contents of the pattern. Okay. And now we're okay. That suggests I don't think I need the thin space pattern in my library, which is okay because it's kind of an oddball. All right. So what am I going to do? Like, what made me blind? I don't know. That's the hard thing to spot. I mean, there's definitely that observability thing that, you know, the pattern didn't have a visible method. Let's see. We had our pattern tests. Yeah, we put this here. Did that get used? It's not clear to me the debugger uses that or not. Because I think that that's what we have when we see the messages, and it shows us a nice little array. So that doesn't do that. Custom debug string convertible. You think that would be what the debugger shows? That visibility thing, that was definitely an issue. I mean, if it had just been there like, oh, I'm an empty array, you know. Okay, so reflections on debugging session. All right, so I guess I'll put that as our work so far today. Okay, so I'm fine. We need to refactor this though. Okay, so I want to say this, right, this stuff, this is actually a function. It's actually a stream function. I don't know if I can write it like that. Let's see how these do. Jump to definition, sure. We don't need a closure. Element transform takes an element that's a closure, and it returns takes a closure that processes one element and it returns an array of elements. Okay. Yeah, so I think we would have to make an extension of the collection or sequence stuff array to put this new function on there. So I'm just going to make it a standalone function. Is that top maker? Yeah. Okay, so this function is, let's see, can you extract this? We're going to put it back, but let's just see if we can do this. No, you can't. Okay. We'll make a method. I'm going to call it intersperse. And you give it an array of pattern. Well, we need to give it whatever this thing produces, array of pattern, yep. And you give it a pattern. And it produces an array of pattern. Okay, and it's this stuff. Okay. Extracted is separator. We'll call this patterns. That seems okay. Repeat separator for patterns.count. Join zip pattern spaces flat map. Okay, I think we'll just make this the return. Return zip pattern spaces flat map dot drop last. Okay, so this we'll take patterns and pattern.thin space. Okay. And then final, we did the drop last. Oops. This is all patterns.reduce. And we're just going to say return all patterns reduce dot 2 dashes. Okay. Does it work? This should work for all of them. Okay. Extract. Well, this problem is make processing a space delimited list of patterns. Produce the patterns from the library separated by thin spaces. Okay. Refactored, which was extract intersperse. And rework pipeline slightly. Not much detail there, but okay. Right. All tests pass, so that's a good place. Interspersed, really, I could see this becoming an array helper method. Boy, am I disappointed I didn't find something directly. So, I've got to take a learning task out of this, I guess. Go learn those sequence methods. Find the ones like zip that you think you should know that don't seem to be there. Lazy views, interesting. I mean, I had no idea there was Swift collection lazy views. Now zips, sometimes you can get 2 numbers at a time. What's this one done? A sequence appears from the 2 underlying sequences. Well, zip is handy if you can zip a list with itself, and then you get a pair of like 1, 2, 2, 3, 3, 4. And like think of the bowling game example where you got 2 rolls that, possibly 3. It would be nice to have this zip 2 that gave you those list of these are the 3 rolls, and then adding them up, you just decide which ones accumulate or not. Okay. Let's run it. And I think what we'll do is we'll create a pattern that reaches all the way to its edge. Okay, that's the space one. We're going to take that out in a minute here. Let's make this one. I'm just going to make a dash slashy kind of thing. Or maybe a downslope of some sort, whatever that means. We'll call it C. Or, yeah. Okay. So that's the C pattern. It touches side to side. If we put them in here, C space C space C space. I'm going to put a bunch of them. So we'll see them go around. Now, the color shift is probably not helping, but you can see the wheel is broken up on the outside. Okay, if we didn't do this, then the stuff would be a solid gold circle. Okay, so that is definitely what I wanted. All right, now do I want to have? I don't think I want the space in the library at this point. I think this is okay the way it is. All right. Let's see. So, where's our stuff? Okay. So we had a task that was pre-populated 1 pixel space. I'm going to take that out. And I think we actually already did it. Okay. Let's see. So what did we just do? We made multiple patterns. What would we call that little text field? Well, main text field. Made multiple space separated multiple patterns in the main text field. Put a thin space between them. Okay. Now let's find that initializer. It's content body, content view. This initial contents space with this junk. All right, so we're not going to bother with initial contents at this point. Let's make sure this works. Whoops, whatever T does, I just did it. Okay, new. I don't know what an X looks like in a nice font, but that's an X. Okay, so we have X. The initial space is gone from our library. Okay. I think you'd be a little hard pressed to tell it's X's. This Tempest view. I do feel like I want to expand this circle someday, make it start out a little bigger. There's a thing with this. If you hold it up to the edge and look at it like that, it'll look normal. I don't know if I can pull it off here. Yeah, take my word for it. It looks normal. Go ahead. I'll give you a chance here. Get your face right up to the screen and look at it long ways on, and you'll see an X a lot more than you see it like this. All right. I don't know. The too many colors I think is probably distracting, but that's okay. All right. So where are we? We have not pre-populated one. We did actually do this. Add 1 comma space between patterns. That's probably a better explanation, isn't it? It's written in human. Okay, pre-populate 1 letter. This was just information I copied. It's no big deal. Okay. Well, require pattern name on a save. Library should be on a grid. Real factor relationship. I don't know. I'm kind of inclined to go for this one. I don't think the pre-populate's going to be hard per se, but it's so boring. Let's see what we got. So I just want to find a 5x7 font. This is the old dot matrix printers. The original ones you saw were often 5x7 because it's just enough to get all your upper and lowercase letters. Dot matrix font. Yeah, I think we were looking at this one. All right. What would be the easiest letter to put in there? Probably I or T. Let's do T. What I would really do, I would like to define this font in as a predefined thing. So your pattern library starts with that, and maybe they all start with underscores or something. I don't know, but or segregate the predefined ones or something. But you don't want to watch me set booleans. I would probably define a little language that let me just put like xxx underscore slash to go to the next line or something like that. I don't know, but it seems like a raw data is no there's no deep interesting thing in there. All right, but let's do T. It's top bar is fully filled, bottom bar is halfway across. Okay, and this is well, this is my version of populating the font for us. I'm just going to do one. So we're going to do T2, and then this is a. Why are you so cantankerous? Ugh. Okay. I don't know why his formatting is so obnoxious. Maybe I can do this and this. This. All right. T goes to, and it's a Boolean array of Boolean arrays. First one is 5 across. True, true, true. Oh, we have a repeating, right? So let's do that. How can I do this? Let's let middle dot equal array. Well, we can just do it. False. Okay. This is array repeating. We're going to repeat true, the top bar of the T, count 5. And then we need 6 copies of middle dot. Okay. Whoops. Oh, am I not allowed to do that? Static. He's pattern of all that. No, that's not going to work, is it? That is not a pattern. Let's just do top bar. Are we repeating true, false, no parens? Then the pattern is top bar, middle dot, middle dot, middle dot, middle dot, that. Extra arguments. Oh. Okay. Like I said, you don't want to watch me do this for every letter. Okay. We would definitely define a little language, but still, it's annoying. Okay. Top bar, middle, 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 middle. 6 middles and a top bar. Okay. Now run it. So what I'm hoping is we get a T that looks like a T, and it shows up in our pattern library as the initial contents. Okay, so patterns. Oh. 5. Should be 7 across. No. It's 5 across and 7 high. Right? Yeah. 5. That's 7. Try that again. Much better. Okay, so now if I came in here, I can make a T. All right, and so what you're seeing is that red ring is the bar that goes all the way across. And this is 1/5. All right, but if I put a bunch of them in there, okay, you can see them a little more. I mean, with a little imagination and a side view. Okay. But that gives us something. So our pattern library doesn't start out totally empty. We can come in and do some stuff. Someday we'd add all this. All right. Oh, okay. Let's see. So this, populate one letter. Okay. Now, require pattern name on a stave. That's actually kind of interesting to me. So I want to make it so if you have all spaces or no letters that you know, something beeps stops you somehow. I don't know. Is that worth the trouble? Okay, let's see. Well, let's find out what it's involved. Okay, so first we pre-populate letter T. So we start with something in the pattern library. Okay. And then this question is on the editing view. Edit pattern view, I guess. Right. So the text field name of pattern, I don't know, can we require stuff to be on it? This is just a Swift UI force text field to be non-empty. Only accept numbers. Can set the type. No. Yeah, so I don't think that's going to be right for us because you start with an empty string, so that's legit. It's really a question of the the save method should should prevent you. So we say library dot add. So we're going to add the pattern. I mean, I guess the thing we could do. All right, let's look at Swift UI text field because maybe just the actual true documentation will explain ways to make this happen. I mean, it used to be you could put, you had your user interface, you put a little text field object out there, you set a few parameters on it that said, like, what stuff's legit. Is editing commit on commit. Okay, maybe that's what we want. Validate. Well, what the heck? It's not on. Where's the real initializer? Those are deprecated. Prompt. Format. Well, this is weird. Did they describe deprecated stuff up there? I mean, you would think that would. No, it doesn't do anything. I thought it might block you or something, but. All right. So can we show an alert? I think that may be something that's going away. Button showing alert equals true. Well, this is my save. Is, I guess, the button we care about. Somebody hits save. I guess if it has an error, we set showing alert equals true and we don't return. Okay, let's see what we can do. Var showing alert equals false. The button action, then we add a dot alert. Name is required. showing alert, and then the alert itself is a button. Okay. Roll.cancel. Okay, is that not what they did? Button, okay, roll, cancel. Oh, this was the iOS 15. That's new. Okay, yeah, so I'm right. It was something changing. What do we do in the old ways? Well, maybe that says I can wait. Visiting alert. Attach this to our form with a two-way binding. Dot alert. Oh, here's alert. Alert is presented. Function value was used as a property. No. I got the alert in the wrong place, apparently. Attach the alert modifier to the form. Well, maybe we don't do the alert thing. Let's revert. Okay, we'll try a different approach. Is that okay? Good. But I see it's time for another break. So let's take 2 or 3 minutes. What we'll do when we come back, we will well, I think we'll just have some extra state. So we'll pass the pattern and the name and the message. And when you go to save, we'll put the message to one thing or the other. Okay. Maybe let's just not do this one. I don't know. I don't think we're going to. It's in an area that's changing anyway, so I don't feel like I really want to learn the old pattern and fuss with that. Okay, but anyway, let's take that break. 2 or 3 minutes. Welcome back. All right. So I think we have half an hour maybe left. Let's deal with this doubles and arcs thing a little bit. I think one of the changes we made was we had the list of booleans and we made that into a pattern. And I think I think we want to do something similar. The doubles are the dash patterns. So when you have an array of these, you really have a dash pattern, the one for each LED. And it makes sense to me that that could be an array of them. Let's see where that shows up. Okay, so we talked yesterday with arc. It's really got the start and end angle and tells you which ring it's on. So it's not much of a class. It's a data bag kind of class, but it's part of the top stuff. And the top itself, the conversion it makes is from this dash pattern into an arc, an array of arcs, one for each LED. This stuff is, well, what is it? I guess I would say this is the actual simulation in effect. So the doubles coming in, that's the list of dashes. You're saying, hey, if you spin this top with these doubles, the top stuff happens. Basically, it turns into arcs, and arcs are kind of what you're going to draw on the screen. So I feel like the input is correct to this thing. We do want to spin a bunch of dash patterns, and the result of that is producing a bunch of arcs. Okay. And this one is just doing one. Is that correct? Yeah, so we run through. Well, again, let's make this dashes. We'll refactor. Okay. And we're pulling this goofy loop with the enumerated because we got to get the index going. Okay, contents of partial result. I mean, we could fold that, but it's okay. Well, can we make that better? I think this would be the same as dashes dot enumerated. That gives us the list of, whoops, dashes dot enumerated gives us, well, it gives us the list of order pairs index dash. Okay. And then we're doing, basically we're mapping each one of those to the spin and building an array. Okay, so we'll map, and this is, I think I can do it like this. Well, it's taking those two things, so I think we can just treat $0, $1 and say spin $0, $1. I think that'll work. Return dashes, enumerated map that. Cannot convert arc to closure type arc. What is spin? It's an array of arcs. Partial result. Oh, maybe do we want flat map? Okay, let's try that. We'll run tests first. So this array of arcs is really all the arcs. Each one knows its own ring, so if you have two on the same ring, showing only part of it twice, those show up twice, two separate items in the list. This list is not, the arc list is just a list of independent arcs. Each one represents some piece of a ring, perhaps the same one twice. Okay, so we don't need result. Okay, so you can see it's nice enough for what it does. That's an improvement. Now this one, I don't know. All right, but anyway, we got dashes. This, we already used the word dash. Good. Okay, but where is it coming from? Callers. Spin new arc, so top maker produces dashes. Let's jump there. Okay, and that's an array of doubles. Sorry. Okay. Let's see. So if where am I producing these doubles? I'm calling two dashes on my pattern. Okay. And well, that I think I can $0 and just avoid the name. And again, I'm just trying to kind of simplify the use of these things. It may have been there because of debugging at some point, or just as we're conceptualizing. All right, and I'll just let tests run while we think. So map of two arc. Two arc starts with an array of booleans, and it produces an array of doubles. I think I would like to say this is a dashes. It's really one dash. This. Okay, so can we make this? How can we make this smooth? Well, dash is going to take. I think dash is going to take this array. So instead of returning the array, we're going to return dash of the array. Okay, so let's make it happen. And then sometimes it's just easier to start in the same class. Dashes. Dash or dashes. I think dash. Maybe dashes. I don't know. All right, so init, it's going to take the dash pattern is an array of double. I think we can make that int at some point. We need to hold one. And I think once you create it, you've created it. So let dash pattern be of type array of double. Okay. So if we return dashes of result. Okay, then this needs to become a dash. All right, we'll just do a build. It should complain at the next level. Cannot convert value of type dashes to closure result double. That can be a dashes. Okay. Now the caller is going to complain. Two dashes to return type double. So he's just returning it, so let's just try that. Okay, we're getting there. Top spin. Jump to definition. We'd like it to take the array of dashes. Okay. And we'd like this to be 1 dashes. Okay, 0 plus dash dot reduce. Well, it would be nice to just say dash dot total. But I think what I'll do is I'll do dash dot dash pattern dot. Let's just make it, let's get this thing back stable. Okay. I don't necessarily want to reveal that thing in the long run, but for now, yeah, we got a bunch of tests that don't know about these things. Dashes, again, I can just put the dash pattern there. And maybe I will make sure the complaint is the right one. Dashes conforms to equatable. Yeah, let's get through this and then fix it up. Dashes. Now you might want to argue I should just put the equality in before we did this stuff, and you're probably right. I thought this would be faster. Oops, dashes. What is dashes? Produces an array of dashes. Oh, maybe we should just go put that in. We left it on pattern. Does not conform. Add the stubs. return left dash pattern equals right dash pattern. So I probably got to take some dash patterns off now. Build one more time. All right, so we extracted a dashes class. Let's do some cleanup. This can certainly come out. Okay, that helps pattern. Where were the places that needed this? It was in top, wasn't it? Top dashes dot enumerated. Oh, that's probably okay because it's dealing with the top level thing. This one, this reduce, yeah, I'd like to get anywhere that did dash, that accesses the dash pattern and make a method out of it. Okay, so if we gave dashes a total method, let's do that. Lost top again. Okay, so his total is the sum of the stuff in the dash pattern. Okay, the sum of the numbers, right? And the other, so let's do dash dot total. And then dash pattern enumerated, index and a width. Trying to see what are we doing with it. Like, should this code 25 down, does it belong on here? I think it kind of does. But the dash pattern enumerated definitely does not. This one, it's a toss-up because it's sort of working with the dash stuff, index width, but it's also working with the ring notion and all that. Ring start angle next end. I mean, is this the job of the... Well, let's get the dash pattern enumerated over there first. Okay, so we'll give it an enumerated method. Does it tell us what that produces? Enumerated sequence of self. Okay. Well, in our case, it's an enumerated sequences of doubles. So it's... I guess it's enumerated sequence of double. All right. Okay, it's not a... dash pattern. Of array of doubles. Sorry. Okay. Yes, we want the braided prints. All right, and back to top. So he should be calling dash dot enumerated, perhaps. And then I guess the information he needs... I don't know, maybe this thing could just belong over there. The delta angle, that feels like something that's owned by the top. I don't know. All right, let's make sure everything's still hanging together. Okay, but I think this is a typical pattern we go through with the refactoring. We create the dummy class or the minimal class, and then we start looking for people who are grabbing dash patterns and see what they're doing with it, and then can we, can we pull that back into the class? So let's just try making this private and see who breaks. Ideally, nobody's looking at it except us. Now, I don't know, the functionality is not super deep here. The total... Okay. And then I don't think there's any reason this has to be double. I'm going to change it to int, and we're going to... Whoops. We're going to do that throughout. Okay, and then as we build, a bunch of places should complain. Let's make a double here because I think that stuff does need to be doubles. Delta angle width. Well, maybe a couple tests. We'll see. Well, if it's testing, it must have built and we're okay, I guess. Yeah. All right. So what we did was we extracted a dashes class, moved in a few methods, changed its type to int. And the reason I did int is because these things are all counts of pixels. There's no doubleness to them. Now, once you get into the arc side, these are fractions of degrees and stuff like that. So, okay, we have a few casts to double in there. But otherwise, I think we are set to wrap up. We've just ordering them. Okay. We already saw the arc, just a bag of stuff about angles. Dashes we just created. Library is this basically a wrapper for the dictionary with a few extra features. The patterns, probably the real complexity of the system right now in here. It's the grid of booleans that represent pixels on or off. And then the top itself. Give me a bunch of dashes, I can produce the arcs for you. And the arcs are suitable for display. And let's see. Well, I guess other kind of functioning classes. This top maker, we did a bit of a makeover there, trying to get the separator stuff and the interspersing, so we got those thin spaces put in between patterns. And I think, yeah, we got to use zip, so that's interesting. Then I think we saw enough of the content body, content view stuff. I mean, basically each screen has its own view, not doing a whole ton of stuff. I mean, this is displaying each pattern in a scroll view, basically a lazy vertical grid. I'm a little confused why it's not showing the columns, and it must be this. Maybe I can. Let's just try adding this super quick. I mean, I think we're saying 250 pixel columns, and that may be more what I wanted. I don't know how many you'll fit, but I think we have about 400 pixels across, 350, something like that. All right, so what we'll do is we'll create a second pattern and see how the grid shows it. It already looks better to me. All right, so just we'll call this random. Okay, alphabetized, a list of 2, and oh, I forgot to name him, but he's Blinky. He would still be first, but that's what I wanted there. Okay, so yeah, that's not a hard thing to do. Pad library should be a grid. Let's put that down in the things done. And we also did this one. Which the real factor relationship turned into turn array of double array of double. into array of dashes. I guess we'd call it a refactor. Okay, well, if you join me for just today or other episodes, thank you for joining. Next week, I've got a basic program, and it's a very old, like a 4K basic. So very, very small, one of the original PCs, and it's like peeks and pokes and stuff like that. So I'm going to take the original code, transliterate it into probably Swift, refactor, rework it, and see if we can kind of put it in a modern framework. I have no idea how fun it'll be or not, but it's basically a little spaceship going through a field of stars and having to avoid hitting things. You know, hot game by 1980 something standards, I guess, but it's sort of not as complicated as refactoring assembly code, but it's got its challenges. So it'll be a little bit about machine transliteration between languages, some about refactoring, some about the little silly game. So I'm looking forward to that. It's probably another 3 to 6 episode kind of thing. We'll see what happens. But anyway, thanks again. Take care, and I'll catch you again.